All right, here we go with the first day of substitution. This is going to be pretty tough to do virtually. And I'm going to tell you right now that you're going to have to be a go-getter and be willing to seek some additional help, some additional resources, because what I provide you probably isn't enough for some of you. We talk about, spending 45 minutes to an hour each day on algebra. Well, if you add that up, that's only 6 hours a day. If the kid is face to face, they're doing 6 hours a day, and then they might have homework when they come home as well. So there might be some days coming up here as things get a little tougher where once in a while you do have to spend some extra time researching it, finding additional resources, additional videos, and things like that. I did a quick Google search on substitution in algebra and found a lot of things. Of course, Khan Academy popped up, amongst others. So it's important that if you don't understand this, you are seeking some avenues to get some answers to help you out. So here we go. Your goal is to solve equations by substitution because we can't always graph and get an accurate answer. It's easy when we're graphing and they make a nice plus sign and they go through whole numbers. But sometimes the lines are so similar, it's just too hard to do with graphing and get an accurate answer. So what is substitution? So I have this written here so you can pause the video and get this down in your notes. It's a way to simplify a system of equations by expressing one variable in terms of another, thus removing one variable from an equation. Remember, we always have two equations this chapter. So what you will notice here in this first example is that we have these two problems. One of them is not solved for y. That actually makes things a little simpler. And they've done some highlighting here, which I think helps. So what they did, they took this 2x and they replaced that in the second equation. And the reason they did that is because these two equations here, so if I got out my highlighter, I thought I had one over here. But, okay, well, these two equations here, let me get rid of this, are equal. And since they're equal, that allows you to substitute things back and forth. So this 2x, because y is equal to 2x, so we know that those two things are equal. And then we know that these two equations are equal. Thus, this 2x can go in for y. So you'll notice when that happens, we go from having two variables to one. And this is really the key right here. We went from two variables here to one. And then you simplify, solve for x. Once we do that, we know that x equals -8. You can plug that back into either equation, and that gives you y. You can see that they took that -8, plugged it in up here. -8 times 2 is -16. So now we know that y is -16, and up here we knew that x is 8. So there's always two parts to this. And then always to check, if we were going to check, which they didn't do on this first one, but I'll show you how we do it. You plug that back into the equation that you didn't use. So you notice that they put this -8 in. They used the first equation, 2 times -8 to get -16. If you did it correctly, you should be able to plug these two numbers in to the other equation, which in this case is -8 plus negative 16 to get a negative 24. Well, that checks. Negative 24 does equal negative 24. That was just using this equation up here. That one's one of the more basic ones. Yesterday we were doing them when they were both already solved for y. You can do that, but then on ones like this, you end up with fractions. And you just don't want to deal with that. But since one of these is already solved for y, if I take this 3x minus 2 and I substitute it right there, then I eliminate the y's from the second equation. So if I substitute, I now have x plus 2, and then I got to do parentheses, 3x minus 2 equals 17. So then I do my distributive property. So that's x plus 6x minus 4. These are like terms, so I combine them. 7x minus 4 equals 17. Add 4. 7x equals 21. Divide by 7. And of course, 21 divided by 7, I get an answer of x equals 3. So now that I know that x equals 3, I can plug this into either equation up here. It doesn't matter. Both will give me the same y. But for simplicity's sake, I'll plug it into the first one. So then I also know that y equals 3, and then I'm going to take my x and replace that with, coincidentally, a 3. And I want a minus 2. So that's 9 minus 2 equals my y. So y equals 7. So now I have both variables. That gives me an answer of 3, comma 7. Now to check it, I always advise you to check these ones. So part of your required work. So we got to check over here. So then we do x plus 2y. So I'm using my other one. Equals 17. So I have 3 plus 2 times 7 equals 17. 3 plus 14 equals 17. 17 just equals 17. It checks. I'm going to do 2 more examples, and then you're going to have 4 problems to do for your homework as well. So again, this one is already solved for x. If it wasn't, which I'll point one of those out in a minute, you would want to solve it for x, or we do have some other methods that we're going to use. But here, I need to get rid of a variable. So now x equals, so you notice up here, this was y equals. Now they've changed it to x equals. So now I'm replacing the x, because since x equals y plus 6, I can replace this x with something that's equal. Since these two are equal, I can replace this into my second equation, and I get y plus 6 plus y equals 10. So that's 2y plus 6 equals 10. Subtract 6. 2y equals 4. Divide by 2. And y equals 2. So this one's going to be pretty easy to check. If y equals 2, then x equals 2 plus 6, so x equals 8. So I get an answer of 8, 2, written as an ordered pair. Well, look over here to check it. 8 plus 2. Does 8 plus 2 equal 10? Well, yeah. Of course it does. So I checked it right there. So all three things we did a substitution, we found our second variable, we wrote an ordered pair, and we checked our work. Last one. Remember, I have to, so I'm going to do this one wrong, so don't write this yet. So if I were to do the wrong substitution, when I rewrite this, I have 2 times 2x minus 1 plus 3y. Don't write this. Now wait a minute. I have an x and I have a y. I'm never going to be able to solve that when I have both an x and a y. It doesn't work. So that tells you right there something with your substitution was wrong. So he had to go back and take another look. Well, from our other examples, we know that we have to eliminate a variable, so we're going to eliminate the y, because y is the same thing as 2x minus 1. Those two are equal. So I'm going to replace it here so that I have 2x plus 3 times 2x minus 1. 2x plus 6x, and then I do my distributive property in both spots. This becomes 8x minus 3 plus 3, and 8x equals negative 4 divided by 8. And now we're going to get a fraction. It's negative 1/2, because negative 4/8 is negative 1/2. So obviously if we had negative 1/2, that would have been pretty hard to graph and find the intersection and know that it is 1/2 and not 0.6 or 1/4 or 1. It'd just be tough to do. You can't do it exactly without guessing. So x equals negative 1/2. So what does y equal? Y equals 2 times negative 1/2 minus 1. So half of 2 is negative 1 minus 1. So y equals negative 2. So my ordered pair is negative 1/2, negative 2. And then we check it, especially since you have a fraction, you want to check it. So I have 2 times negative 1/2 plus 3 times negative 2. And I'm going to write it over here, and it has to equal negative 7. So it doesn't. Half of 2 is 1 plus our negative. So negative 7 equals negative 1, and 3 times negative 2 is negative 6. Well, negative 7 equals negative 7. It does check. So again, I did my substitution. I found my second variable. I wrote an ordered pair. I checked my work. We're going to skip 5 to 8 today. This is the notes part too, so we'll touch on those Friday or maybe next week. So in your assignment, it's 1 to 4 on page 9. I don't think you have any. I looked at these before and was checking them in my head. None of these will be your no solution on 1 through 4, but 5 and 6 get a little trickier because if you notice on number 5, like I had previously mentioned, none of these are solved for a single variable. So you would have to, if you were using substitution, you would have to do some moving of things around, which actually in this case, you would just add 6y and then divide by negative 1, and then you'd have x by itself. But it does add extra steps. But all these other ones, you'll notice though, like this one here, I'll give you a hint. the substitution is right here. So you end up with negative x plus 4 equals 3x. And then you need to make sure that you move a variable to one side and solve it. But down here, you'll notice on 3 and 4 that you have an x and or on number 4, not on number 3. Sorry. You have an x and a y. Well, that gives you a little bit of flexibility on which one you want to solve. You could put this 2y in down here and get rid of the x. Or you could take the 3x minus 7 and substitute it in for y. You can go either way there, and it would work. So again, 4 problems to go with the 4 that I did. Have a great day.